Here, S. What makes the March 2026 total lunar eclipse truly special after this blood moon fades back to its normal silvery glow? We will not see another one for a very long time. In fact, the next total lunar eclipse will not occur until New Year's Eve of 2028, ringing in 2029 with what astronomers are already calling the New Year's blood moon. That means we are looking at a gap of nearly 2.5 years without a single opportunity to watch the moon turn completely red for skywatchers and casual observers alike. This makes March 2026 a must-see event. The numbers behind this eclipse tell a compelling story. The magnitude reaches 1.150, which means the moon passes deep into Earth's shadow, rather than just grazing the edge. This results in full obscuration with 100% of the lunar surface swallowed by the umbra. The total phase, when the moon is completely red, lasts for 58 minutes. That is nearly a full hour to watch our natural satellite bathed in that eerie copper glow from the first moment the moon enters the penumbra to the final stage of the eclipse. The entire event spans 5 hours and 39 minutes. There is another layer of intrigue here as well. This eclipse coincides with the worm moon, the traditional name for March's full moon. The timing is remarkably precise. The moon reaches its peak fullness at 11:38, which is roughly 30 minutes after totality begins, so as the moon is turning blood red, it is also reaching the exact moment of full illumination in its monthly cycle. This convergence adds a certain poetry to an already rare astronomical event for anyone who has ever wanted to witness a blood moon. March 2026 offers one of the best chances in years, and the long drought that follows makes it all the more precious. To really understand what happens during a lunar eclipse, you have to picture Earth floating in space with the sun behind it. That sunlight streams past our planet and casts a shadow out into the void. But here is the thing about shadows: they are not all the same darkness. Earth actually casts two distinct shadow zones. The penumbra is the outer region where the sun is only partially blocked by Earth. If you were standing on the moon in this zone, you would see the sun mostly still shining, just with a chunk missing where Earth blocks part of it. The light dims slightly, but it is subtle. Then there is the umbra, the inner cone of complete shadow. Here, Earth blocks the sun entirely from the umbra. The sun has vanished behind our planet, and that is when the moon turns that deep coppery red. Astronomers track an eclipse through specific contact points. It starts with P1, when the moon first touches the penumbra. Most people cannot even notice this phase. Then comes U1, the moment the moon reaches the umbra and the partial eclipse truly begins. You see a dark bite taken from the moon's edge. U2 marks when the moon is fully inside the umbra and totality begins. The whole disk turns red. G stands for greatest eclipse, the moment of maximum coverage. Then the process reverses. U3 ends totality. As the moon starts exiting the umbra, U4 marks the end of the partial phase. Finally, P4, when the moon leaves the penumbra completely, and the eclipse is over. Now, you might wonder why this does not happen every single month. After all, the moon goes through all its phases on a regular cycle. The answer lies in orbital geometry. A lunar eclipse can only happen when the moon is exactly opposite the sun from Earth's perspective. That only occurs during full moon, but the moon's orbit is tilted about 5 degrees relative to Earth's orbit around the sun. Most months that tilt carries the moon above or below Earth's shadow cone. The three bodies simply do not line up perfectly. Only when the moon happens to be crossing the plane of Earth's orbit at the same moment it reaches full moon do we get an eclipse. The moon turns that deep crimson color during totality. And this is where the term blood moon really comes from. It is not just a dramatic name someone invented. The moon genuinely appears red, and the reason is fascinating. You might hear people use the terms red moon and blood moon interchangeably, but there is a subtle distinction worth understanding. A red moon simply describes what you see during any total lunar eclipse when the moon takes on that coppery hue. Blood moon is the more evocative term that has become popular in recent years, particularly in media coverage. Some people reserve it for eclipses that appear especially vivid or deep red, but scientifically speaking they describe the same phenomenon. So what is actually happening up there during those 58 minutes of totality from 11:04 to 12:03 UTC? The moon sits completely within Earth's umbra. You would think it would go pitch black, but it does not. The moon still receives light, but that light has taken an extraordinary journey. Sunlight, streaming past Earth, has to pass through our atmosphere to reach the moon. Our atmosphere acts like a giant filter. Blue light gets scattered in all directions, which is actually why our sky looks blue during the day. But the red wavelengths, the longer ones, push through. They bend around our planet, slipping through the atmosphere and continuing onward to illuminate the moon. The result is that eerie copper red glow. Every sunrise and sunset happening around the world at that moment contributes its light to that red beam reaching the moon. You are essentially seeing all of Earth's sunrises and sunsets projected onto the lunar surface at once. The exact shade can vary depending on atmospheric conditions, volcanic activity, and dust in the air. Sometimes it is a bright copper, sometimes a deep rust color, but it is always that unmistakable red. Let me walk you through exactly how this eclipse unfolds minute by minute, using universal coordinated time. The entire event spans nearly 6 hours from start to finish, and each phase has its own distinct character. The eclipse begins subtly at 8:44 UTC, when the moon first enters Earth's penumbral shadow. At this stage, you would not notice anything dramatic happening. The penumbra is that outer shadow zone where Earth only partially blocks the sun, so the dimming is extremely gradual for over an hour. The moon simply appears slightly less bright than usual, and most observers would struggle to detect any change at all. Things get interesting at 9:50 UTC, when the partial eclipse begins. Now, the moon starts slipping into the umbra, that dark inner shadow where Earth completely blocks direct sunlight. This is when you can actually see a dark circular bite taken out of the moon's edge. Over the next hour and 14 minutes, that shadow creeps across the lunar surface, swallowing more and more of it. Totality arrives at 11:04 UTC, and this is the moment everything changes. The moon becomes fully immersed in Earth's umbra and begins to glow. That deep coppery red. Maximum eclipse occurs at 11:33 UTC. Right at the midpoint of totality. The total phase lasts 58 minutes and 19 seconds, giving observers nearly a full hour to take in the blood moon in all its crimson glory. Totality ends at 12:02 UTC, as the moon begins emerging from the umbra. The partial eclipse continues until 13:17 UTC, with the shadow retreating across the lunar surface in reverse. Finally, the penumbral phase wraps up at 14:23 UTC, and the eclipse is complete. Those penumbral phases bookend the entire event, totaling 2 hours and 12 minutes combined. The partial phases add up to 2 hours and 29 minutes, but that window of totality, just under an hour, is what everyone will be waiting for. Now, let us look at who actually gets to see this eclipse. The visibility footprint is genuinely massive, stretching across most of the planet. If you look at a world map, the eclipse will be visible from at least some parts of Eastern Europe, across virtually all of Asia and Australia, through North America and South America, and over vast stretches of the Pacific, Atlantic, and Indian Oceans. Even the Arctic and Antarctica get a piece of the action. But here is the surprising part: while the eclipse sweeps across all those regions, it will not be visible at all from Africa or most of Europe. If you are in Milan or London, or standing at the historic Greenwich Observatory, the moon simply will not be above your horizon. During any of this, the entire event happens while the moon is below the horizon for those locations. When you translate this into actual human beings, the numbers become staggering. About 5.58 billion people, representing nearly 69% of the world's population, can see at least the faint penumbral phase. Around 5.17 billion can catch the partial phases. But the real prize totality will be visible to about 3.34 billion people, roughly 41% of humanity. Here is what really stands out. Though only 176 million people, just over 2% of the global population, are positioned to watch the entire eclipse from the very first penumbral contact until the very last, everyone else will have the moon rise or set partway through. For those wanting to watch totality in their local time, here are the conversions on the Pacific coast of North America. The blood moon window runs from 3:04 to 4:03 in the morning on March 3rd for the East Coast. That shifts to 6:04 to 7:03 in the morning over in Japan and Korea. You are looking at the evening of March 3rd from 8:04 to 9:04 at night. Eastern Australia sees it from 10:04 to 11:03 that same evening, and for New Zealand, the clock crosses midnight, with totality running from 12:04 to 1:03 in the early hours of March 4th. One of the best things about watching a lunar eclipse is how simple it is, unlike solar eclipses, which require special glasses to view safely. A lunar eclipse poses absolutely no risk to your eyes. You can look directly at the moon throughout the entire event, without any protection. The moon is simply reflecting sunlight, and during an eclipse it becomes dimmer rather than brighter. So if you are lucky enough to be in a region where the eclipse is visible, all you really need is your own two eyes and a clear view of the sky for the best experience. Find a location away from bright city lights. Light pollution will not stop you from seeing the eclipse, but it can wash out the subtle color variations during totality. The deep reds and oranges show up much better under dark skies. Bring a chair or blanket, because this is a slow event lasting nearly 6 hours. Dress warmly, especially if you will be outside in the early morning hours. If you want to photograph the eclipse, a camera with manual settings gives you more control than a smartphone. The moon is surprisingly bright, so start with a low ISO and fast shutter speed. As the moon darkens during totality, adjust your exposure accordingly. A tripod helps enormously, especially during the total phase, when longer exposures become necessary. For those in Europe, Africa, or anywhere the moon will not be visible, you still have excellent options. Time&Date.com will host a live stream starting at 9:30 on March 3. Griffith Observatory in Los Angeles will broadcast from 12:30 Savento 6:25 in the morning Pacific Time, which is 8:37 through 14:25 AT. The Virtual Telescope Project also hosts an international live event with feeds from multiple locations worldwide. This lunar eclipse is actually part of an eclipse pair. About 2 weeks earlier, on February 17, 2026, an annular solar eclipse will occur. These paired events always happen within the same eclipse season. So, if you are following astronomical events, you might want to mark both on your calendar.